Imagine a world not above us in the stars, but directly beneath our feet, sealed away by millions of tons of pressurized, ancient ice. For centuries, we looked at the frozen wastes of Greenland as a static, crystalline desert, a geographic blank space on the map where nothing happens and nothing changes. But in the closing months of 2024 and the dawn of 2025, that perception didn't just shift, it shattered. A collaboration led by Harvard University's Department of Earth and Planetary Sciences began releasing data that felt less like geology and more like a challenge to our understanding of the natural world. They found a ghost in the machine of the Earth. Using ultra-wideband ice-penetrating radar and gravitational mapping, they looked through the northwestern corridor of the Greenland ice sheet and saw something that shouldn't be there. It wasn't the jagged, chaotic mess of standard bedrock. It was a shape, massive, geometric, and repeating, locked under 2 kilometers of solid ice. This formation, spanning 38 kilometers in length, defies every model of volcanic or erosional activity we possess. It is a structured anomaly that suggests a level of organization in the Earth's crust that we have never documented, and the dating suggests it has been there since long before the first human looked at the sky. To understand why this discovery is so disruptive, we have to look at the sheer scale of the environment where it was found. Greenland's ice sheet is a monster of nature. It covers 1.7 million square kilometers, a frozen shield 5 times the size of Germany, pressing down on the bedrock with such immense weight that it actually deforms the Earth's crust. For most of modern history, this world was a mystery. We could only guess at what lay beneath. We assumed it was a silent graveyard of ancient mountains and riverbeds, ground down by the slow, relentless movement of the glaciers over 2.6 million years. Early maps were blurry and speculative, based on primitive seismic echoes. But as technology evolved, so did our vision. We transitioned from guessing to seeing. The development of airborne ice-penetrating radar allowed us to strip away the white veil of the ice. NASA's Operation Icebridge was the pioneer, flying over the frozen reaches for a decade and revealing hidden canyons that rivaled the Grand Canyon. But Icebridge was just a rough sketch. The new Harvard-led survey used next-generation sensors capable of resolving details at a level of precision that makes previous maps look like finger paintings. When they flew over the Englefield Land Plateau, they weren't looking for a mystery. They were looking for data. What they found instead was an architectural scale anomaly that has forced a quiet, intense reevaluation of terrestrial geophysics. The anomaly itself is a geometric titan. Located 1.8 kilometers deep, the structure presents as a series of repeating angular ridges. In nature, we are used to the fractal, the jagged, irregular patterns of a coastline or a mountain range. Nature loves curves and chaos. It does not typically produce 38-kilometer-long rectilinear grids or hexagonal honeycombs in bedrock. When the first radar returns came in, the research team naturally assumed it was a technical error. In the high-stakes world of subglacial research, noise is the enemy. Radio waves can bounce off meltwater pockets or be distorted by internal layers of compressed snow, creating phantom images. The team flagged the data as a glitch and moved on. However, science is defined by replication. When they returned months later with different instruments and different flight paths, the structure didn't vanish. It grew clearer. It was consistent, physical, and massive. By cross-referencing the radar with gravitational data from the GRACE and GHOST satellite missions, which measure the density of the Earth's crust, the team confirmed that this wasn't a trick of the light or a radar artifact. There is a massive, high-density structure embedded in the Greenland bedrock that follows a geometric logic we cannot yet explain. Dr. Anna Petrov and the Harvard team have been remarkably careful in their public statements. In an era of viral misinformation, they have remained tethered to the data. They are not claiming that this is an artificial structure. They are not suggesting it was built by a lost civilization or an extraterrestrial hand. Those are the stories we tell when we are afraid of a vacuum in our knowledge. Instead, they are pointing toward a much more uncomfortable scientific truth. The Earth is capable of processes we don't understand. The formation is estimated to be hundreds of thousands of years old, perhaps much older. This places its origin in a time when the Earth was a very different place. It's still a place ruled by the laws of physics. If this is a natural formation, it represents a lost geological process, a way for the planet to organize matter into geometric precision at a scale that dwarfs our cities. It challenges the standard models of how heat, pressure, and minerals interact deep within the crust. We are looking at a 14-kilometer wide honeycomb of stone and wondering if we truly know the planet we live on. One of the most compelling natural theories involves something called columnar jointing, but even this falls short. Most people are familiar with the Giant's Causeway in Ireland, those beautiful, interlocking basalt columns that look like a staircase for giants. That happens when lava cools and shrinks, cracking into hexagonal shapes. It is a perfect example of geometry in nature, but there is a problem of scale. Basalt columns are measured in centimeters or meters. The Greenland anomaly is measured in kilometers. There is no known precedent for columnar jointing to scale up by a factor of 10,000. Another theory suggests mantle convection cells, where the molten interior of the Earth rises and falls in a rhythmic pattern, potentially stamping a geometric shape into the underside of the crust. But again, the precision of the angles in the Greenland data is far more defined than any convective model predicts. We are left in a scientific no-man's land, where the thing we see with our own eyes doesn't fit into any of the boxes we have built to contain the natural world. The age of the formation is perhaps the most humbling aspect of the discovery. Ice core data from projects like GRIP and GSB2 allow us to read the history of Greenland like the rings of a tree. We know that the ice above this anomaly has been there undisturbed for at least 800,000 years. This means that whatever force shaped the bedrock, it did so before the ice arrived. It did so in a deep pre-human past. To put that in perspective, our species, Homo sapiens, has only existed for about 300,000 years. All of recorded human history, every empire, every war, every invention, is a mere heartbeat compared to the time this structure has sat in the dark beneath the ice. It is a relic of a deep-time Earth, a version of our planet that existed before we were even a thought in the evolutionary process. This realization shifts the mystery from who made this to what is the Earth truly capable of. It suggests that our planet has a capacity for complex, large-scale organization that doesn't require life or intelligence to manifest. It is the intelligence of physics and chemistry operating at a scale we can barely fathom. This discovery has sent ripples far beyond the community of geologists. It has caught the attention of planetary scientists at NASA and the Jet Propulsion Laboratory. If Earth can hide a massive geometric structure under 2 kilometers of ice for nearly 1,000,000 years, what does that mean for the rest of the solar system? We are currently planning missions to Europa, the moon of Jupiter, and Enceladus, the moon of Saturn. Both are worlds encased in thick shells of ice, with vast, hidden oceans beneath. We have always wondered if life could exist in those dark waters. But the Greenland discovery suggests we should also be looking at the structure of the worlds themselves. Could the floors of those alien oceans be covered in geometric formations we can't yet imagine? Could the geology of an icy moon be even more complex than the geology of a rocky planet like Mars? Dr. Elena Vasquez of JPL has noted that the Greenland anomaly serves as a test case for our instruments. If we can't fully explain a structure on our own planet, we must be incredibly humble when we begin to map the surfaces of other worlds. As we move through 2025, the investigation is intensifying. This isn't a one-and-done news story. It is the beginning of a decadal research project. The next steps involve deploying seismic sensor arrays across the ice surface. By using control vibrations, essentially thumping the ice, scientists can listen to the echoes that bounce back from a structure. This will allow them to create a true 3D ultrasound of the formation, revealing whether it is hollow, solid, or composed of different mineral layers. There is also the radical possibility of a deep drilling mission. Drilling 2 kilometers through the toughest ice on Earth to retrieve a single core of rock is one of the most expensive and difficult tasks in science. But the reward would be the holy grail of geology, a physical piece of the anomaly. Analyzing the crystalline structure of that rock would tell us once and for all if this is a volcanic fluke, a tectonic masterpiece, or something else entirely. We often feel that the age of discovery is over. We have GPS, satellite imagery, and deep-sea submersibles. We think we have categorized the world. But the Greenland anomaly reminds us that we are still just scratching the surface. We live on a thin crust floating over a sea of fire, wrapped in a blanket of ice and air. We are guests on a planet that is far older and far more mysterious than our map suggests. The formation in northwestern Greenland is a gift to our curiosity. It is a reminder that there are still monsters in the map, not literal dragons, but scientific puzzles that demand our best minds and our deepest humility. Somewhere under that ice, there's a shape that has waited for 1,000,000 years to be seen. It doesn't care about our theories or our politics. It simply exists, and now that we have seen it, we cannot unsee it. We are committed to the long, slow work of understanding what the Earth was doing in the dark, long before we arrived to ask the question. The Greenland discovery is a testament to human ingenuity, but it is also a lesson in the limits of that ingenuity. We use the most advanced radar in history to find it, yet we still don't know what it is. This tension between our ability to see and our ability to understand is where science lives. It is the drive to close that gap that pushes us forward. Whether this formation turns out to be a new type of metamorphic crystallization or a unique signature of the Earth's early cooling, it will change the textbooks. It will remind future students that geology is not a dead science of dusty rocks, but a dynamic, unfolding mystery. As we look toward the future of the Greenland surveys, we do so with a sense of excitement. We're no longer just mapping the ice. We are mapping the history of a world we are only just beginning to know. The universe is vast, but the Earth is deep. And in that depth, the anomalies are waiting. In the coming years, as the data from the seismic surveys and potential drilling missions begins to trickle in, we will likely find ourselves faced with more questions than answers. That is the nature of the frontier. We are standing on the edge of a new understanding of terrestrial complexity. We are learning that the Earth is not just a ball of rock, but a sophisticated system capable of producing order from chaos in ways that mimic the work of an architect. The Greenland hexagons, as some have started calling them, may be the first of many such structures discovered as our radar technology continues to improve. Perhaps Antarctica holds similar secrets. Perhaps the floor of the Pacific Ocean is home to geometric wonders we haven't yet reached. The discovery in Greenland has pulled back the curtain, and now we are looking into the shadows with new eyes. We are a curious species, and when we find a shape in the dark, we won't stop until we know why it's there. The story of the Greenland anomaly is ultimately a story about perspective. From the surface, the ice looks flat, cold, and empty. But from the perspective of the radar, it is a transparent window into a hidden realm. It teaches us that the most profound discoveries often require us to look past the obvious, to look through the ice of our own assumptions. As we continue to study this 38-kilometer enigma, we are doing more than just geology. We are practicing the art of wonder. We are acknowledging that for all our technology, the Earth still holds the power to stun us into silence. The geometric structure beneath the ice is a message from the deep past, written in a language of angles and symmetry. We're just now learning how to read it. And as we do, we find that the world is much larger, much older, and much stranger than we ever dared to dream. Stay curious, because the Earth is far from finished with us.